Welcome, thanks for joining. So we're talking about Chapter Z here, Introduction to Statistics. So in this section, we're going to be talking about measures of center, dot plots, and describing the shape of a data distribution. We start with something very basic, looking at the mean here. Now you've all heard of and used a mean before. It's just your arithmetic average of a set of numbers. And the symbol that we have for it is this X with a line on top, which is pronounced X bar. So this means mean, the arithmetic average. And we have a little bit of a formula for this. X bar is equal to. So what do we do when we're taking an average or an arithmetic average? What we do is we add all of the terms in our set together and then divide by the number of terms. So the way that we can write that sort of notationally is going to be a sub 1 plus a sub 2 plus so on and so forth until we get to a sub n. So a sub 1, a sub 2, that just represents, some term, some other term, and that dot, dot, dot just is etc. Like we're going to have an infinite number of things or can have an infinite number of things in between there until we get to the last term. Then we divide all of this by n, the number of terms that we added together. And, notationally that looks a little bit weird, but you guys know how to do this already. So here, if I'm finding the mean of this set of numbers, I have 5 plus 9 plus 14 plus 23 plus 13 plus 19 plus 41 over, there are 1, 2, 3, 4, 5, 6, 7 terms. When we add that together, we get 124 over 7, which is 17.714. So there we have our arithmetic mean, our X bar. Notationally, again, that is just how we write that we are finding an arithmetic mean. All right, so moving along, we also have here the median. For median, we can define this as the midpoint. I have a lot of lines here that are not necessary. The midpoint of a frequency distribution. And we can add just the fact that half the data lies above and half the data lies below. So to find the median, you do the following. First, arrange the observations from smallest to largest. That's the most important thing, and it's the thing that we often overlook, is arranging those from least to greatest. If there are an odd number of observations, then the center number is your median. If there's an even number of observations, then you have to take the arithmetic average, meaning the mean, of the two center numbers. So just for this example, if I organize this from least to greatest, and you'll notice what I do is I check off, so -5, -2.3, looks like 1 is next. I can't really get that point. Looks like 3. Then we have 8, 8.4, 12, and 14.2. So in this set, we have 1, 2, 3, 4, 5, 6, 7, 8 different numbers. And if I now go to find the median of them, you cancel off from left and right. A little bit tricky here because I used decimals. So you can see here, I have 3 and 8 as my center numbers. And what I do is I take the arithmetic average of those. So 3 plus 8 over 2, which gives me 11 over 2, or 5.5. So there our median is 11 halves, or 5.5. And again, that's telling me that half of the data in this set will fall above that, and half of the data in this set is falling below that. All right, next we're going to talk about quartiles and the interquartile range. So your first quartile is the median of the lower half of data. So it's the median of just the lower half of data. What that means when we talk about it being a first quartile is that a fourth of the data will fall below that point. The third quartile is the median of the upper half of data. So again, it being a quartile, a fourth or 25% of the data is falling above that third quartile. And then your interquartile range, that's your IQR. Sorry, this is your Q1 and Q3 is how you can see them notationally. Your IQR is the middle 50% of data. So essentially your IQR, when we're talking about that, IQR is equal to Q3 minus Q1. Because 25% is below Q1, 25% is above Q3. So the span in between Q1 and Q3 is where half of your data is. So again, calculating Q1, you're just going to take the median from the left. Calculating Q3, you're going to take the median from the right. We'll do this in the examples pretty quick. I'd recommend just giving it a try on your own first. So next, we're going to talk about an outlier. An outlier, the way that we're going to define that is an observation point that is distant from the trend of data. So an observation point that is distant from the trend of data. The thing about this definition is that that word distant is a little bit ambiguous. Like, how do I know if something is considered distant or not really that distant? So we came up with a way of identifying outliers. So outliers are going to be considered any single data point that falls above 1.5 times the IQR, above the third quartile, or 1.5 times IQR below the first quartile. We call these fences. So essentially, if you have a data point that is not within the fences, it is considered an outlier. So your formula for an upper fence is Q3 plus 1.5 times the IQR. And your formula for a lower fence is Q1 minus 1.5 times the IQR. Then we're going to determine whether your previous data set has an outlier. So we're talking about this set of data, and I'll do that in the examples just since I'll continue using that same one. I'm going to need all that information anyways. So next, a 5-number summary and a box plot. So your 5-number summary, when we talk about what that is, it's just 5 pieces of information that give a lot of data about your set. So it's the minimum, then the Q1, the median, M, median, Q3, and the maximum. Remember that this M is not mean. Mean is X bar. And what we're going to do with this is make a box plot. So to make a box plot, what you're going to do is arrange a number line horizontally. Essentially, just like sort of graphing where you're going to make your x-axis, you're going to make a number line horizontally. And then you're going to plot a line at each of the 5 numbers. Once you've done that, you're going to draw a box around Q1 through Q3 and whiskers, what are called whiskers, at min and max. That might seem a little bit confusing, but it's very easy to just come up with that graph. You want to know how to graph that so that if a graph is given, you can also interpret from that. Because that's the great thing about some of these graphs is that, you know, if I just give you a 5-number summary and I give it to you as a box plot, you can pull a lot of information out of that just based off of a graph. instead of seeing like a whole giant span of numbers. All right, moving along. We also then have a dot plot. A dot plot is a graph that's used to display, frequency. And I'm just going to give a quick example of what a dot plot looks like. I'm making this up as I go. So if we had the data like 1, 4, 7, 8, 4, 4, 1, 7, 6, 3, 1, 7, 9, 2, 4, 1. So we have that list of data. In order to make a dot plot, what I'm going to do is again start with that same idea of horizontally spanning these numbers. I'm sorry, making a number line, not spanning the numbers. And you want this number line to start at your lowest number, so 1. And then you're going to include every number that's in between there. So 2, goodness, 3, 4, 5, 6, 7, 8, 9. If we had a very large spread of data, we could, sometimes not have to go by 1s. We can go by 2s or 3s. We just want to make sure that we're including everything that's within there. And then we're just going to plot a dot. Sometimes you could use an X as opposed to a dot, because dots, you might not draw them clear enough, but I'll draw dots. So 1, I'm going to draw a dot. There we go. 4, I'm going to draw a dot. 7, I'm going to draw a dot. Next we have 8. Then 2 4s and a 1. So what we do is we continue stacking these higher. 7, 6, 3. So that we can show how often these show up. 1, 7, 9. 2, 4, 1. Okay, drawing dots was really hard on here, sorry. So now looking at just this graph, I have the same information, but I get an idea of where data is either clustering or where it's separated apart. I can see here that every number is used except for 5. And I can see that there's a larger amount sort of here on the right. There's 10 numbers over here versus just 6 over here. So it gives me an idea of the clustering. On that topic of clustering, we have what we call a standard deviation. So all the previous things that we've talked about, median, mean, that's not particularly new to you, but a standard deviation is. Standard deviation is a way of measuring the average distance of observations from their mean. So all of this data has a mean, an arithmetic mean. The standard deviation is a way of measuring the average distance of each one of these points from whatever the mean of this entire data set is. What it measures is the spread of data around the mean. So it's talking about how clustered the data is around its mean versus how spread out it is around its mean. A standard deviation of 0 would mean that there is no variability. Everything is really just at the mean. As the standard deviation gets larger, the data is going to become more spread out, which also means that it's going to have a larger range. Remember that range is when you're talking about just the minimum to the maximum. So our range here is just 8. But as my standard deviation gets larger, that's going to be a key way of knowing that data is more spread out and there's a larger range. All right. Moving along, we talk about symmetry. So this symmetry and skew is going to be a way of determining sort of, or describing more so, the data in a set. So data is considered symmetric if the left and right sides of the graph are approximately mirror images. And that's a huge thing there, is that it's not that they're mirror images. They don't have to have the same number of observations on the left as they do on the right. They have to have approximately the same number. So you're talking about something that looks like this, where most of your data is over here, there in the center, and you have roughly the same amount of data on the left as you do on the right. Again, it doesn't have to be exactly the same amount. Skew to the right, it describes data in which most data falls on the left side of the graph, with fewer but larger data values falling to the right. When we talk about skew, if we say skew to the right, that means that the direction, or that gives us the direction that the tail is pointing. So skew right, sorry, I almost drew that backwards, would mean that our data looks something like this, where we have a large portion of our data here, but we have a couple data points along here, or even just maybe 1, 2, 3, 4 data points over here that are pulling this data to the right. So again, the skew is telling me what direction this tail is pointing. This tail is pointing to the right. Skew left is going to look the opposite of that. So we have data that looks like this, where again, I have a few data points over here, and then I've got tons of data all over here. Understanding the idea of a skew, we'll get into how that really helps us, but it's a way of describing the overall trend of data. You know, if I'm to look at something like test results in honors pre-calc, what I'll often see is something that's skewed to the left. Because that means that I have tons of grades that are, you know, like let's say that right here was a 60%. I have tons of grades that are above a 60%, and then I've got a couple that are not quite there. If I had something that was symmetric, some of you might think like, oh man, that might be great, but it depends on what this mean is. If this mean is 70, that means that half of you, roughly, are falling below 70, and half of you, roughly, are falling above 70. Skew right, you know, that would possibly be really bad. If I have most of my data over here, well, I don't know what is over here. If this is 80 and this is 60, then that's fine. So it's not just that the picture is going to tell you if it's good or bad. You're still going to have to know what is the mean, what is the standard deviation, what is the range in which this graph is working with, and that we'll all get to. All right, so some of this stuff can be super irritating to pull up or to calculate by hand. You know, you think about a mean, and if I give you like 6 numbers, yeah, that's fine. But if I give you like 130 numbers, that becomes super difficult. One, because it's time consuming, and two, because we lose track of where we are a lot of times. So you can use a calculator to pull up a report of what are called one variable statistics. There we go, write this. The way in which we do that is all listed here. We'll go through that in class, so I'm not going to talk about it right now, but you could follow this process. I've put it on there so that you can refer back to it. And then down here, I have included some important things. When you do this one variable statistics report, you're going to get all of this data pulled up immediately. You will have to type in all of the data, but organization that you type it in does not matter. So you don't have to organize least to greatest. All you have to do is type in all the numbers. Again, we'll go over that. But here, X bar, that's going to tell us that we're finding the mean. Here, when we have this nice, wonderful sort of OX looking symbol on the calculator, that's going to be your standard deviation of a population. S sub X, that's standard deviation of just a sample. So, you know, if I were talking about the standard deviation of my third period pre-calc, that is just a standard deviation of a sample because it's not all of the honors pre-calc courses. If I talk about the standard deviation of all of the honors pre-calc courses, that would be this wonderful OX symbol, and we'll talk about that still. N is just the number of elements in the set. Sometimes that could be helpful if you realize that you and your friend are getting different one variable statistics. If you look at N, a lot of times what happened is you forgot one of the numbers So you're going to see that you have different n values. Min x is the smallest element in the set, minimum. Q1 is your first quartile, m is your median, Q3 is your third quartile, and then max x is the largest number in the data set. We'll go over how to do that because we're going to use that in order to do this problem. So that is just some introductory topics to statistics. We're going to do a lot of applications with it. We're going to build on it in section Z.2. So make sure that you get the fundamentals and the how-tos and the ability to read a graph down for now.